One important assumption of regression is that the variance in residuals is homoscedastic or constant. In this lecture, I will discuss how we can test for the presence or absence of homoscedasticity. We can use graphic and non-graphic tests. The graphic method plots residuals versus fitted values. The graph should not show a pattern. If it does, then there is heteroscedasticity. We will first run multiple regression and then command RVF plot. R stands for residuals, V for versus, and F for fitted values. Here are my variables. So my regression command is reg, then dependent variable murder, followed by number of violences, then urban population, white population, high school population, and poverty. Now this is my regression output. Now we shall run the graphic command, which is rvf plot. Now here is the graph, and we find that residuals have a pattern. It's a declining pattern. Then we also have an extreme value, which is an outlier. Therefore, from the graph, we can conclude that there is heteroscedasticity. We can use non-graphic tests. One such test is Bruce-Pagan test. The command for that test is HET test. The null hypothesis is that variance is constant. If p-value is greater than 0.05, then the null hypothesis is rejected. You can see that chi-square is very high and probability is significant even at 0%. Therefore, this test indicates to us that there is heteroscedasticity. Another non-graphic test is Cameron-Trivedi IM test, and the command for that is IM test. Now once again we find that there is heteroscedasticity, there is presence of kurtosis, and heteroscedasticity is significant. The null hypothesis that variance in residuals is homoscedastic, and since the p-value is greater than 0.05, null hypothesis will be rejected. Similar results are given by White's test. White test is preferred sometimes, particularly when residuals are not normally distributed. And the command for that is White STS. Now, well, the spellings have been written incorrectly. White followed by TST. Now again, you find that chi-square is very high and p-value is highly significant. Heteroscedasticity results in wrong estimates of standard error, though coefficients of variables will not be affected. One solution for this is to use robust command after regression model. So we write our regression command murder followed by independent variables, and then we add the command robust. Now after running this command, what we see is that the standards are robust standard errors. If we compare our results with the earlier results, we will find that the coefficients are the same, but then standard errors are different. And what we notice here is that the standard errors, they change. Now you will also find that some of the variables, now white for example was significant at 10% level, but now it has become insignificant. So after running command robust with regression, we are able to correct for standard errors.